Hey everybody. I wanted to go through bootstrapping one more time, and I wanted to use my paper example as a course for analysis here. So I don't know if you guys have found this. It's there in the Blackboard shell somewhere, but there's also a direct link right here. I think there's a couple of direct links hanging around. I will be honest with you, I direct link because that way I can make some edits and change it in a whole bunch of places at once. Okay, so anyway, this is my paper, right? So 2019 Stanley Cup analysis. So I'm down here in project part 4. Project part 5, right after my hypothesis test. You didn't do your hypothesis test, clean it up. Correctly, clean it up. I want to talk through this comparing of the two proportions, though. So the first part of the project, I do the comparing of the mean to -1, and I am able to reject my null hypothesis. The Blues were a good team that year. When I get down into the next part, I want to look at the proportion of the wingers, and I want to compare the proportion of the left wingers to the proportion of the right wingers. They should be the same, but they're not in this data. Those two values were a little different. So I actually, excuse me, I actually go through here and I do two bootstraps. I do the left wingers and I do the right wingers. And I get a confidence interval for each of these. So I get a confidence interval of 14% for the left wingers here. I get a confidence interval of 14% to 18%, and for the right wingers, I get a confidence interval of 12 to 16%. Now, originally, the number of right wingers was 14%, unless that's right in the middle here, but that does fall in this data set, and the proportion of left wingers was 16%. That also does fall in the confidence interval for the right wingers. So both of those statistics, fall in the confidence intervals for the other ones. So I don't have anything to suggest that those two are different. It is important when you're comparing two statistics that you look at the confidence intervals of both of them. They might be different. One confidence interval could be wider or narrower. If you guys notice here, my standard errors are a little different. They are a little different. So that might make a difference when we're computing, where it might be like if I just did one bootstrap, the other statistic didn't fall into it. But if I did the second bootstrap, the confidence interval might be a little wider and it might pick up that value. So you do need to be careful with that. Watch out for that. That can sometimes throw people off. But in this part of the project here, I'm going to fail to reject because my statistic falls in the other confidence interval. So that's what we're always looking for here. Does the statistic fall in the other confidence? Does the statistic fall in the confidence interval? Does your null hypothesis, right? Does your null hypothesis contain the other? And this one does. So unfortunately, when it does, I fail to reject my null hypothesis. I have evidence to suggest that these are the same. I don't have evidence to suggest that they're different, even though the statistics were different, but I don't have evidence to suggest that they are. Okay, so good luck with your bootstrapping. Again, I got resources out there. Look around, and hopefully you guys can get this. All right, keep working hard.